Hello dear students, today we are going to start chapter 3, current electricity. So first of all, we will go through introduction. In chapter 1, all charges, whether free or bound, were considered to be at rest because we were discussing about electrostatics. Okay, so let me write the keywords for you. Electrostatics. So the branch of physics that deals with charges at rest. But now charges are in motion and they constitute an electric current. So you can highlight this term. So charges in motion constitute an electric current. Such currents occur naturally in many situations. Sometimes these things happen naturally, like you can say lightning is one such phenomena in which charges flow from the clouds to the earth through the atmosphere, sometimes with disastrous results. जब लाइटनिंग होती है आपने देखा भी होगा बारिश से पहले तो चार्जेस बेसिकली फ्लो कर होते हैं क्लाउड से अर्थ की तरफ थ्रू द एटमॉस्फेयर और सम टाइम आप लोगों ने न्यूज पढ़ी होगी लाइक कुछ बंदों पे लाइट गिर गई है ठीक है नाउ दे आर इन मेडिकल विद यू कैन से सीवियर शॉक द फ्लो ऑफ चार्जेस in lightning is not steady but in our everyday life we see many devices where charges flow in a steady manner. So what is this word steady? Steady means when the value remains same. Numerical value remains same throughout. Okay, then we can call it a steady current. Like if I am saying I1, you can say I'm saying 10 ampere. After some time, I notice current again, I can say I2, it is again 10 ampere. So I can say the current is steady. And if the value is changing, we can say non-steady. Like water flowing smoothly in a river. So when water flows smoothly in a river, we like that view. But when water flows drastically, like you can say during cyclone, so that flow we don't like. A torch and a cell-driven clock are example of such devices. Torch and cell-driven clock, examples of such devices in which steady flow of charge is there. In present chapter, we shall study some of the basic laws and concerning steady electric current. Okay, so this is all about the introduction part. Now the first topic is electric current. The symbol you can say I. It is in a small area held normal to the direction of flow of charges. Like this is kind of consideration or you can say imagination. Mm, you are having a small area held normal like angle is 90 degree to the direction of flow of charges. Both positive and negative charges may flow forward and backward across the area. Okay, I can say if negative charge is flowing from B to A, then I can say positive charge may be flowing from A to B. In a given time interval T, let Q plus be the net amount, that is forward minus backward, of the positive charge that flows in forward direction across the area. Similarly, we will have Q negative be the net amount of negative charge flowing through the area in forward direction. The net amount of the charge flowing across the area in forward direction in the time interval T will be Q positive minus Q negative. Because we know, let me erase this one. First of all, electric charge, I can say electric charge is AC. You can make your symbols. Electric charge. This is a, if I write about keynote point, this is a scalar quantity. So we can add the charges as we add algebraic numbers in mathematics. The symbol is, you can see, symbol for electric charge denoted by Q. And what is the SI unit? SI unit, you can say coulomb, denoted by capital C. And this is all about electric charge. You may know about this. And if I talk about dimensions of electric charge will be, we know the formula for Q is I multiplied by T time, where I is electric current, T is time, and we know the SI units, SI dimensions for these. For current, you can say current, we can say this is given by ampere A1. For time, we can say T1. There is no mass, so we can say M0. There is no length, we can say L0, and put it in a square bracket. So these are the dimensions for electric charge. So first of all, you need to find the net amount of charge flowing in time T. Now this is proportional to T for the steady current and the quotient. Then we can have a mathematical expression for electric current. And electric current mathematically given by this equation. This I is electric current. This Q is electric charge. And this T is time for which that specific amount of charge flows through a wire. So you can define it as the current across the area in forward direction. This is given by I is Q by T. If it turns out to be a negative number, it implies a current in the backward direction. So because we can't say the current is minus 2 ampere, it simply means if I assume direction to be like this, A to B, then direction needs to be reversed. Then the final answer should be something like from B to A. Again, electric current is also a scalar quantity. Currents are not always steady. We know this. This is a very difficult task to maintain a steady current. very much similar, like a student find it difficult to maintain their performance in each and every test, in each and every exam. Like if the student scores 16 out of 20 in first, you can say weekly test, then in the next test, it may be possible the score will increase, it may be possible the score will decrease. So maintaining a steady value of anything is a difficult task to do. And hence, more generally, we define the current as follows. Let delta Q be the net charge flowing across a cross section of a conductor during the time interval delta T between the times T and T plus delta T, because we need to consider two different instant of time. Then the current at time T across the cross section of the conductor is defined as the value of the ratio of delta Q to delta T in the limit of delta T tending to 0. So this is, we can define I electric current as a function of time, that will be equal to limit delta T tending to 0 delta Q over delta T. And when we will be solving this mathematically, we can sometimes write it as dq over dt, derivative of Q with respect to time. In SI units, the unit for current is ampere. The symbol is capital A. An ampere is defined as through a magnetic effect of current that we will study in the following chapter. We can see simply 1 ampere is nothing. If 1 coulomb of charge flows through a wire in 1 second, then I can say current in that particular wire will be 1 ampere. An ampere is typically the order of magnitude of current in domestic appliances. You can see, like I'm using my laptop, and here on the charger it is written like the value for input current is, let me check it. It is given as 1.7 ampere. So the amount of current flowing through wire, you can check different appliances. For example, in my laptop charger, I am finding the value as 1.7 ampere. An average lightning carries current of order of tens of thousands of amperes. Now just think about this number. Lightning consists of 10,000 amperes, 10K. And at the other extreme, current in our nerves are in microamperes. Microamperes means 10 to the power minus 6 ampere. Okay, so this is the small introduction part. You can type in your questions in the comment section, and I will suggest you to read each and every subject NCRT book line by line, word by word, so that you get clarity, because you will find so many words, and then when you will try to express those words in your own language, then you will be getting the concept, and it will help you to boost up your fundamentals. Okay, don't try to cram anything. There are some data we need to cram. That is it. Like we need to cram SI units, their dimensions. This we can't do anything. But for derived units, we need to follow some process. We need to follow some steps. Okay. So next time we will be doing 3.3 electric currents in conductors.